Hi geometry kids, this is Mrs. Youngman again, and today we're going to be looking at angles. But before we get into angles, there's a couple things you need to know, a little bit of vocabulary. The first thing is what a ray is. An array is a portion of a line that has what we call an initial point, and then it goes forever in one direction from that initial point. So a ray would have a point, let's maybe call it A being the initial point, and then it's going to go forever in one direction from there. So the way we're going to name a ray is we're going to have that initial point being A, and then it continues forever in one direction. So I'll just write continues in one direction. So the way it would be named is we'd have another point someplace in that direction. Maybe this one's called B. I could name this ray AB, and I draw a little ray over top. If there were more points on this ray, like maybe there was another point here and this was named C, I could name this ray AC also. But unlike lines and segments, I cannot switch these two letters around, because that first letter always has to be that initial point or kind of that beginning point for that ray. So I could name this ray AB because it starts at A and then goes in the direction of B. I could name it AC because it starts at A, goes in the direction of C, but I couldn't switch those around and call it CA because that would start here and go forever that direction. So you can't switch rays around like you can lines and segments. The next thing would be opposite rays, and opposite rays we need to know are collinear, and if you remember what that means that they're on the same line, so they're collinear and they share an initial point. So if you're drawing a picture of this, it's probably easier to draw a straight line, or as best of a straight line as you can do. And then put a point someplace. It doesn't have to be right in the middle, but I just drew one there. Let's call that point, I don't know, let's go with R. And then I'll put some other points on here. Let's call this S, and let's call this point over here T. Well, this basically just looks like a straight line, but it's made up of two rays that are collinear, and they have that same initial point. So an example of opposite rays would be ray RS and ray RT are opposite rays. And the way you're going to see this is it might just say in the direction that a couple things are opposite rays. That's just kind of letting you know that that's a perfectly straight line, because sometimes it's kind of hard to tell if it just kind of looks like a straight line or if it actually is, and they're going to denote that in the directions by just saying these are opposite rays. Okay. That being said, we're ready to get into our definition of what an angle is. An angle, the definition is that it's two rays that share an initial point. So if I draw two rays that share the same initial point, then it would be made up of, that would be the angle. So this entire thing is an angle. And if I label these rays, let's call this one AB, and this right here is AC. Those are known as the sides of the angle. So the sides would be the two rays that connect at that initial point. The place where the two sides come together is called the vertex. and the vertex is a point, a singular point where those two rays meet. The vertex would be point A, and I can label that just with a capital A. And then the name of this entire angle, there's actually multiple ways that we could name it. So I'm going to draw an angle out front, and I could name this angle BAC. I could name this angle CAB. And it wouldn't matter which direction I went, but that vertex does have to be that middle letter, either way that I name it. And because this vertex is only there for one angle and there's not more than one angle that meet here, I have another way I could name it. I could simply just name this angle A, and that would be okay. I'll show you in a minute, but we can't always just use one letter for it. And another way would be if this had like a little number on the inside, so maybe this had a little number 1 in between those two sides, then I could also name this angle 1. And I'll show you over here with this picture. There's actually a lot of different angles that are formed. This is supposed to represent, like at a school, if these are different sidewalks. You can see here that there are a lot of different angles that are formed. So let's say I wanted to, let me change the color here. Let's say that I wanted to talk about this angle right here. Well, that vertex is B, but I can't just use the one letter B because there's another angle here with that same vertex. So there's a lot of different ways I can use to name this angle. The easiest way would just be calling it angle 2 because of this 2 here. Sometimes though there aren't numbers on the inside there, so then you just have to pick 3 letters. You wouldn't have to use all of these, you could just choose one. So I could name this angle DBC, or I could have done DBK or DBL, or the reverse of any of those would have also worked. Let's do one more. I'll choose red for this one. Let's say I wanted to name, I don't know, this angle right here. So if this were my angle, again, I could just say angle 5. And because that number is there, I would probably definitely go with that because it's just easier and it's easy to locate. But if I didn't have that number there, I could have called this angle ACJ. Okay, or GCB, or you can see that there are a lot of different options. So sometimes for your work, you'll just want to make sure you're being careful about how you're naming these, but you have a lot of different choices. Okay, looking at the same picture here, we have some different ways that we can talk about these different angles, and these words I'm sure I'll just review, but we have different acute angles. So acute angles are angles that are less than 90 degrees. And an example of that might be something like this angle here. It's probably about 60 degrees if I were just eyeballing it. So an example of an acute angle here would be maybe angle 5 or angle 4. Both of those would be acute angles. Angle 1 would also be an acute angle. So I'll just give one example. Angle 4 here in the picture is acute. It is less than 90 degrees. A right angle is exactly 90 degrees, and that's going to look like a perfectly written L. So this would be a 90-degree angle, and you'll see a little box on the inside if it's noted that it's a 90-degree angle. So this picture here, it wasn't meant to show you that these are 90-degree angles because there is no little box, and you're going to find out that you can't just assume that they are, but they look like they're about 90 degrees just by the look of the picture. Anything that's perpendicular is going to be that exact 90-degree angle. And obtuse angles are more than 90 degrees, but less than 180. And I'll just write less than 180. The book doesn't have you write down exactly 180 degrees. Those are called straight angles, and you may have learned that in a previous math class. Our book doesn't get into that though. So you won't be, let me rewrite that. I don't like the way that turned out. Yeah, that's not much better. But this right here is an obtuse angle, and looking at the picture, looks like angle 2 is an obtuse angle, angle 3 is an obtuse angle. So if you want to write an example of that, that would be maybe a good idea too, if you copied this picture down. If you didn't copy the picture down, then all of these aren't going to make a whole lot of sense in your notes. So use your best judgment on that. Okay, the next little bit, congruent angles. Congruent angles have the same measure. So they are angles with the same, or you could say equal measures. And the way that that will show up on a picture is with some congruency marks. So let's say I have this angle here, and I have this angle here, and if I try to make them look like they're the same measure, you'll see one arc in each one, and that would let you know that they're congruent. Or if one had 2 arcs and 2 arcs, that would let you know that those are congruent too. So congruent angles will have the same or equal measures, and we're going to be setting up some examples to where we can set them equal to each other and use some algebra then to do some solving for those. Grab another color. This one's kind of light. An angle bisector is a ray that splits an angle into 2 congruent angles. And remember, congruent just means that they're equal. So a ray that splits an angle into 2 congruent, or think 2 equal angles. And if you just think about like it's splitting it right in half. So again, this is just a rough sketch of what this would look like. The angle bisector would come here, and it would go right through the middle to where this arc and this arc both have the same number of little lines through them. That would show you that these 2 angles here are congruent. And if I wanted to name these, if I just call this point A and this point B and this point C, and let's say this is D here, I would know that this angle, so I'll name this angle ADB. So I could write that angle ADB is congruent to, remember this from a previous lesson, the symbol means congruent, is congruent to angle, and I could call this one either CDB or BDC. Remember, the order doesn't matter as long as the vertex is right in the middle. So let's call it BDC. And if you want to make a little note, because you're not familiar with this yet, that symbol, remember, means that they are congruent. And congruent just means that they are equal, their measures are the exact same. So if one was 45 degrees, the other one would be 45 degrees also. Okay, and then the last thing you're going to have to do in this section, beyond naming some angles and answering some questions about their sides and the vertex, we'll be setting up some algebra problems with them. So I have this example here. Sometimes for angles, it gets a little complicated the way it's all written out. So it's going to be really important that you're labeling your picture, and you probably will want to maybe trace or draw out the different diagrams so that you can write over top of them in your notes or on your assignment. So this says in the figure, KJ and KM are opposite rays. So KJ and KM, that's just telling you that this is a perfectly straight line. So this will be important later on, but this would be 180 degrees. And on this side would also be 180 degrees also. And then it says that KN bisects angle JKL. So I like to always just trace over that, JKL, and this is bisecting it. So what I would also do at this point is then give each of these kind of one arc or two arcs, whatever your preference is, to show that these two angles are congruent, meaning these two angles have equal measures. And then I'm going to go over top here and label this. So angle JKN, so JKN, that's this angle here, is 8x minus 13. And angle NKL, so NKL, this angle here, is 6x plus 11. And they want us to find angle JKN, and I'm just going to circle that so that I know what I'm asked to find in the end.
Mom?
Hey buddy, I'm in the middle of making a video, okay? I'll help you later. So I have 6x plus 11 equals 8x minus 13, because I know those two angles are congruent, and that means that they have equal measures.
I'm gonna talk to you a quick thing. Who are you talking to?
I'm talking to my students right now on the computer. You can't see them.
But Mom, I'm so thirsty.
Well, then you better go get a drink.
Can you get up here?
No. Shut the door, please.
Okay.
Okay, so back to the math. We have to subtract 6x from each side, and then we have to add 13 to each side. So just so you know, that was my youngest son, Colby, and when I said I was talking to my students, he was like looking very closely at the computer like, what are you talking about, Mom? I do not see any students in here. So, yeah, you might hear a little bit. I'm at home right now making this. So what I want to do now, since I've solved for x and x is 12, I'm not trying to find x, I'm trying to find the measure of angle JKN. So just make sure you always go back and pay attention to what you're solving for. So I'm going to substitute this in. So 8 times 12 minus 13. So let's see, 8 times 12. If I multiply this out, we have 16, that's 96. And then 96 minus 13 is 83. So we have 83 degrees for this. If you wanted to, you could also plug that in here, and you would find that 6 times 12 is 72, and then add 11, you also get 83 degrees. Sometimes they may ask you for this whole thing, so then you'd have to add the 83 degrees and the 83 degrees together. Or like I said at the very beginning, knowing that all of this adds up to 180, they might ask you for this part here, and then you just have to figure out 180 minus 83 minus 83. So they could ask this question a lot of different ways, and it's not like you need to do anything different. Just make sure you're always paying attention to what they want you to find in the end, so you're not getting a partial credit answer for not answering the question all the way. I hope you guys found this helpful, and maybe Colby was even a little entertaining. I will see you guys next time. Have a great day.